Hello everyone and welcome back to the Sleep Science Lab. Here on this channel, I share real-life encounters with beings from beyond the skies to help you unwind and drift off to sleep. Before we dive in, I would love to hear from you. Leave a comment and let me know where you're tuning in from. Now, find a comfortable spot, relax, and let's begin. Close your eyes if you like, or simply let your gaze go soft. There is nothing you need to do right now, nowhere you need to be. The day is done, or at least this moment belongs entirely to you. Let your shoulders drop. Let your jaw loosen. Let the weight of everything you have been carrying today settle gently down, the way snow settles, the way dust settles in a quiet room after everyone has finally gone to bed. We are going on a journey tonight, a very long, very slow, very peaceful journey through the universe. Not the sharp and busy universe of news and noise and notifications, but the other one, the real one, the one that has been humming along quietly for nearly 14 billion years, patient and enormous and full of the most extraordinary things you have ever almost imagined. We are going to visit galaxies. Strange ones, beautiful ones. Galaxies so far away that the light reaching your eyes from them left its source before the Earth had even finished forming. Galaxies that spin. Galaxies that collide with each other in slow motion over millions of years, like two enormous soap bubbles drifting together in a breeze. Galaxies that are almost entirely made of dark matter, ghostly and barely there, like a whisper in a cathedral. Galaxies that glow with the light of a trillion suns, and along the way, I am going to tell you real things, true things, astonishing things, because the universe, it turns out, is stranger and more wonderful than any story anyone has ever invented. You do not need fiction when reality is this extraordinary, so breathe in slowly, hold it just for a moment, and breathe out. Let's begin with something close. Relatively speaking, our own galaxy, the Milky Way, is a barred spiral galaxy, which means that at its center there is not just a point or a smooth oval, but an actual bar of stars stretching across the middle, like a luminous rod embedded in the heart of a pinwheel. This bar is roughly 27,000 light-years long. If you could somehow drive along it at the speed of a commercial airplane, it would take you approximately 290 billion years to reach the other end. The universe itself is only about 13.8 billion years old, so that bar is, in travel time terms, about 21 universes long, and yet, from where we sit, on a little rocky planet orbiting a medium-sized yellow star about 26,000 light-years from the center of the galaxy, the Milky Way looks like a soft smear of light across the night sky, a brushstroke, a watercolor suggestion of all those hundreds of billions of stars. Our galaxy contains somewhere between 100 billion and 400 billion stars. Scientists aren't sure of the exact number. They make their best estimates using the total mass of the galaxy and the typical mass of stars within it. But there is always uncertainty, always a beautiful vagueness at the edges of what we know. The Milky Way is, in a sense, too large to count precisely, the way you might not be able to count every grain of sand on a beach simply by looking at it from above. And the Milky Way is just one galaxy. There are, as best as astronomers can currently determine, roughly 2 trillion galaxies in the observable universe. 2 trillion. That is a 2, followed by 12 zeros, 2,000 billion. If you counted one galaxy per second without ever stopping, it would take you 63,000 years to count them all. Longer than all of recorded human history multiplied several times over. Each of those galaxies contains its own stars, its own planets very likely, its own clouds of gas and dust and possibility. The numbers become so large that the human mind does not actually grasp them, not really. We say the words and we nod and we move on, but somewhere deep in the body, there is a faint tremor of recognition that something truly enormous is being described. Let that enormity settle around you like a blanket. It is not frightening, it is comforting. You are a small creature on a small world in the outer arm of a medium-sized galaxy, and the universe is incomprehensibly large, and you are here, right now, breathing, and that is something remarkable. Let's go further out. The closest galaxy to our own is a small dwarf galaxy called the Canis Major Dwarf Galaxy, discovered only in 2003. It sits about 25,000 light-years from our Sun, which actually makes it closer to us than the center of our own Milky Way. It is being slowly torn apart by the gravitational pull of our galaxy. Its stars stretched out in long streamers that wrap around the Milky Way like a cosmic scarf slowly unraveling. There is something quietly poignant about that image, isn't there? A small galaxy, drifting too close to a larger one, slowly being absorbed. Its stars will over billions of years become part of our galaxy. They will join our 100 billion star family. The Canis Major Dwarf Galaxy will cease to exist as a separate thing, and instead its components will be folded in, incorporated, the way a small river meets a large river, and eventually you cannot tell where one ends and the other begins. But for now, it is still there, if very gradually coming apart. You could, in theory, Look in the right direction on a clear night and know that what you are seeing is the light of stars from a dying galaxy, slowly being embraced by our own. That light has been traveling for 25,000 years. The photons entering your eyes were released from their source stars before the last ice age had fully ended, before the first cities were built, before anyone had ever written anything down. They have been crossing the void for 25 millennia, and they arrive now, tonight, and fall upon you. Let your breathing slow a little more. In, out. Good. The Large and Small Magellanic Clouds are two irregular dwarf galaxies visible from the southern hemisphere of Earth. They look like detached pieces of the Milky Way, bright smudges of light hanging in the sky like luminous clouds. Ancient peoples in the southern hemisphere knew them well. The indigenous Australians, the Maori, the peoples of Polynesia and South America all had their own names and stories for these ghostly patches of sky. The Large Magellanic Cloud is about 160,000 light-years away. The Small Magellanic Cloud is about 200,000 light-years away. Both are satellites of the Milky Way, meaning they orbit us, or rather, they orbit the common center of mass that we all share. The Large Magellanic Cloud is home to one of the most extraordinary stellar nurseries in the local universe, the Tarantula Nebula. It is a vast cloud of gas and dust where stars are being born at a frantic rate, illuminated from within by some of the most massive stars known to exist. If the Tarantula Nebula were as close to us as the Orion Nebula, which you can see with the naked eye in the winter sky, it would be bright enough to cast shadows on Earth at night. It would be the brightest thing in the sky after the sun and moon. You would be able to read by its light. Instead, it is a faint smudge, only visible from the southern hemisphere, and then only under dark skies. It glows with the light of 100,000 suns, but distance has tamed it to a whisper. There is something about this that I find deeply soothing, that great and blazing things can be tamed by distance. That intensity, transported far enough, becomes gentleness, that a stellar nursery roaring with the birth cries of new suns can become, from far enough away, a soft glow in the darkness, like the way the noise of the day softens into the quiet of the night, like the way everything does, if you give it enough time and distance. Now let us travel to our nearest large galactic neighbor. The Andromeda Galaxy, also known as Messier 31, sits about 2.5 million light-years from us. It is the most distant object visible to the naked eye under good conditions, a faint smear of light in the constellation Andromeda, easy to miss if you do not know where to look, unmistakable once you do. Andromeda is a spiral galaxy, much like our own though somewhat larger. It contains perhaps 1 trillion stars, compared to our galaxy's estimated 2 to 400 billion. When you look at Andromeda with the naked eye, you are seeing the combined light of 1 trillion stars blurred together into a single soft patch of luminescence. 1 trillion separate fires, each burning for millions or billions of years, each orbited by planets that we will almost certainly never visit or even see, all reduced by distance to a single smudge of light smaller than your thumbnail held at arm's length. Andromeda is approaching us, not quickly by human standards, but at about 110 kilometers per second, relative to the Milky Way. It is steadily drawing closer. In approximately 4.5 billion years, the Andromeda Galaxy and the Milky Way will collide, or rather, they will pass through each other and merge over the course of a few billion years. This sounds catastrophic. It is not. Galaxies are mostly empty space. The stars within them are so spread out that even when two galaxies interpenetrate each other, it is very unlikely that any individual stars will actually collide. The solar system, if it still exists at that point, will be largely unaffected. The sky will look very different, full of the streaks and swirls of stellar material mixing together, but the Earth, or wherever we are by then, will probably continue on without any direct calamity. What will emerge after billions of years of mixing and reshaping is a single large elliptical galaxy, no longer spiral, just a smooth, rounded cloud of stars. Astronomers have even given it a name, in anticipation, Milkomeda, or sometimes Milkdromeda. I like Milkomeda. It sounds gentle, it sounds like something that belongs in a warm and quiet place. Let your body sink a little more into whatever surface it is resting on. Feel the support beneath you. There is no need to hold yourself up. The world will hold you. Let's go somewhere more unusual now. About 56 million light-years away, in the constellation Virgo, there is a galaxy called Messier 87. It is an elliptical galaxy, one of the largest known galaxies in the observable universe, containing somewhere between 1 and 7 trillion stars. But what makes it particularly famous, what makes it perhaps the most iconic galaxy in contemporary science, is what lives at its center, a black hole. Specifically, the first black hole ever directly imaged by human beings. In April 2019, the Event Horizon Telescope collaboration released a photograph of the shadow of the supermassive black hole at the center of M87. It showed a bright ring of superheated gas glowing orange and gold, with a dark circle at the center where no light could escape. The black hole at the center of M87 has a mass of approximately 6.5 billion times the mass of our Sun. It is, in the most literal sense possible, incomprehensibly massive, and yet the image was almost tender in its appearance. A ring of glowing warmth with a dark center. A cosmic eye looking back at us across 56 million light-years. The light in that image left its source when dinosaurs had been extinct for only 10 million years. When mammals were still relatively small and unambitious creatures. When there were no humans, no human ancestors, nothing yet on Earth that had any concept of a universe at all. And that light crossed 56 million light-years of nothing to land in a series of radio telescopes carefully synchronized across the surface of our small planet, operated by a team of scientists who had spent years preparing for that moment. That dark circle in the bright ring is a place where physics as we understand it breaks down. A singularity, a point of infinite density, or something we do not yet have the mathematics to describe. Light that crosses into that dark circle does not come back. It is swallowed, and the universe beyond, for anything that falls in, becomes completely inaccessible. Breathe in, breathe out. We are not falling in. We are 56 million light-years away, watching from safety, and even from that distance the image is extraordinary. Now let us visit something different, something strange and beautiful in a completely different way. In the constellation Sculptor, about 13 million light-years away, there is a galaxy called NGC 253, also known as the Sculptor Galaxy, or the Silver Coin Galaxy. It is a spiral galaxy seen nearly edge-on from our perspective, which means instead of looking at it face-on and seeing the full pinwheel shape, we see it tilted, almost like looking at a dinner plate from the side. Its disk of stars stretches across our field of view in a long, narrow band, glowing with the warm light of hundreds of billions of stars. What makes it unusual is the extraordinary rate at which it is forming new stars. NGC 253 is what astronomers call a starburst galaxy, meaning something, perhaps a past interaction with another galaxy, has triggered an unusually high rate of star formation. The galaxy is essentially having a baby boom of new stars, regions of gas and dust collapsing into new solar systems at a rate far higher than in a quiescent galaxy like our own. New stars form the way all things form, gradually through the accumulation of smaller things drawn together by gravity. A cloud of gas dust, drifting in the void between stars, begins to collapse. As it collapses, it heats up. As it heats up, it begins to glow. If enough mass is gathered, if the temperature at the core rises to about 10 million degrees Celsius, nuclear fusion ignites. Hydrogen atoms begin fusing into helium, releasing energy, and a star is born. It takes somewhere between 100,000 and several million years for a star to form. And yet, in a starburst galaxy like NGC 253, this is happening constantly, across the whole disk of the galaxy, at a rate that makes the galaxy glow with unusual intensity. All those new suns, all those potential solar systems forming around them, all those possible worlds. There is something wonderful about the sheer ordinary miracle of star formation. The universe does not need to be told to make stars, it simply does. Given the right conditions, gas collapses and stars appear. It has been doing this since about 100 million years after the Big Bang, and it has not stopped. You could say the universe is, in some deep sense, interested in stars. Not in the way a person is interested, not consciously or deliberately, but in the structural way. Give it matter and energy and time, and it will reliably produce stars. Let your attention drift, the way smoke drifts, the way thoughts drift when you are almost but not quite asleep. There is a galaxy called Centaurus A, about 13 million light-years from Earth, one of the brightest and most studied radio sources in the sky. It is a large elliptical galaxy, in the process of swallowing a smaller spiral galaxy, and the merger has disrupted both enough to trigger violent activity at the center. A supermassive black hole there, estimated at 55 million solar masses, is actively feeding on infalling gas and matter, and the energy released by this feeding is ejected in two enormous jets of plasma that extend for thousands of light-years out of the galaxy in both directions. These jets are moving at close to the speed of light. They are columns of superheated plasma, threaded through with magnetic fields, roaring outward from the center of the galaxy like the exhausts of an inconceivably powerful engine. If you could somehow see in radio waves, Centaurus A would be one of the most dramatic sights in the sky. The jets, invisible to our eyes, are enormous, dwarfing the visible galaxy itself, but even in ordinary light, Centaurus A is remarkable. The collision of the two galaxies has produced dark dust lanes across the face of the elliptical galaxy, giving it a strange banded appearance, like an eye with a dark stripe across it. It is distinctive enough that it was noticed and catalogued by James Dunlop at the Parramatta Observatory in Australia in 1826, who described it as a beautiful nebula. He did not know, of course, what it was. He could not have known. The tools and concepts needed to understand it would not exist for another century. But he saw it. He looked up into the sky above New South Wales and pointed his telescope and saw the faint glow of 13 million years of travelling light and called it beautiful. He was right. Feel the weight of your eyelids if they are beginning to drop. There is no need to fight it. Let them rest. Let me tell you about a galaxy that is in its own way the most unsettling and beautiful thing I know of in the universe. It is called Dragonfly 44, and it was discovered in 2016 by a team using a telescope array called Dragonfly, which is designed to detect extremely faint diffuse objects. Dragonfly 44 is a galaxy in the Coma cluster, about 320 million light-years from Earth. Here is what is strange about it. Dragonfly 44 has about the same mass as the Milky Way. Its total mass, inferred from how its stars are moving, is comparable to ours, and yet when you look at it, it is almost invisible. It is dim, diffuse, a faint smear of light. Where the Milky Way has hundreds of billions of stars, Dragonfly 44 appears to have almost none, at least in proportion to its mass. What is it made of then, if not stars? Dark matter. Almost entirely dark matter. About 99.9% of Dragonfly 44's mass is dark matter. Its ordinary matter, its stars and gas and dust, is vanishingly small compared to its total mass. It is in effect a ghost galaxy, a massive thing that barely exists in any form you can see. Dark matter is one of the great mysteries of modern physics. We know it exists because we can see its gravitational effects. Galaxies rotate in ways that only make sense if there is far more mass present than we can see. Galaxy clusters bend light in ways that require more mass than is visible. Something is there. Something that does not emit light, does not absorb light, does not interact with ordinary matter in any way we have yet detected except through gravity. And Dragonfly 44 is almost entirely made of it. It is a galaxy that is mostly nothing we can see. A vast shadow of invisible material holding a tiny sprinkling of actual stars the way a deep, dark ocean holds a handful of bioluminescent creatures. Just enough light to tell you something is there. Almost nothing you can actually see. There is something deeply soothing about this idea, actually. That most of the universe is invisible to us, that what we see, all the stars and galaxies and nebulae and planets, all of it, is only about 5% of what actually exists. The rest is dark matter and dark energy, things we can infer but not directly observe. We are living in a universe made mostly of mystery, and we are fine. The mystery does not threaten us. It simply surrounds us, invisible and patient, and the little bright things we can see go on shining within it. Breathe in slowly, breathe out. Let me tell you about the Cartwheel Galaxy. About 500 million light-years away, in the constellation Sculptor, there is a galaxy that looks like nothing else in the sky. The Cartwheel Galaxy is a ring galaxy, which means that instead of the familiar spiral shape or the smooth ellipse, it looks like a wagon wheel or a bullseye. There is a bright, compact nucleus at the center, and then a gap, and then a bright outer ring, connected to the center by thin spokes of stars. This shape was caused by a collision. Sometime in the past, perhaps 200 or 300 million years ago, another smaller galaxy passed directly through the center of what was then a normal spiral galaxy. The impact sent ripples outward, like dropping a stone into still water. Those ripples are rings of star formation, moving outward through the galaxy, compressing gas and triggering the birth of new stars as they pass. The outer ring of the Cartwheel Galaxy is one of the most active star-forming regions known. It is the leading edge of that ripple, still propagating outward, still triggering the birth of new suns as it moves. When the James Webb Space Telescope observed the Cartwheel Galaxy in 2022, it revealed details never seen before. Knots of new stars being born in the outer ring, streams of gas and dust connecting the nucleus to the ring, the subtle textures of a galaxy in the process of rebuilding itself after a catastrophic collision. Because that is what galaxies do. They collide, they disrupt each other, they scatter stars in long streams across the void, and then slowly, over millions and billions of years, they settle back into new shapes, they reform. The star formation continues. The new stars light up the restructured galaxy. Life, if it exists anywhere in them, continues. Nothing in the universe is ever simply destroyed. It is transformed. The Cartwheel Galaxy is being transformed, and even in its disrupted state, it is making something new and radiant. Let that sit with you for a moment. Let me tell you about a place called the Coma Cluster. The Coma Cluster is a large cluster of galaxies, one of the first to be clearly understood as a cluster, located about 320 million light-years from Earth. It contains over 1,000 galaxies, most of them elliptical and lenticular, moving through a region of space together, bound by their mutual gravity. Between the galaxies in the Coma Cluster there is hot gas, heated to tens of millions of degrees, so energetic that it glows in X-rays. This intracluster medium, as it is called, is actually more massive than all the stars in all the galaxies combined. It is the background material of the cluster, the substance that fills the space between galaxies, the way water fills the space between islands. When galaxies fall into the coma cluster, they encounter this hot gas, and the gas strips material from them in a process called ram pressure stripping. The galaxy's own gas is torn out, like the hair of a swimmer being pulled through water. This is one reason why most galaxies in dense clusters like coma are elliptical or lenticular rather than spiral. Their gas has been stripped away, so they cannot form new stars, and over time they settle into smooth, featureless shapes. There is a kind of poetic sadness in this, and also a kind of peace. A galaxy that has lost its gas, that can no longer form new stars, grows quieter. Its existing stars age. The bright blue young stars die first, leaving only the longer-lived yellower and redder ones. The galaxy fades slowly over billions of years, like an ember cooling. In the very distant future of the universe, when all the gas has been used up or stripped away, when no new stars can form anywhere, the universe will enter what cosmologists call the degenerate era. The existing stars will slowly burn out. The universe will cool and darken, not all at once, but over incomprehensible timescales. The last red dwarf stars will flicker out perhaps 10 to the power of 14 years from now, 100 trillion years, about 7,000 times the current age of the universe. That is a very long way. For now the universe is still young and bright and making things. And you are here, inside it, breathing, and the light of 1,000 galaxies is falling on the Earth even now, passing through the atmosphere, touching everything, though we feel none of it. Let the weight of your arms and legs settle. There is no tension needed. You are supported. You are safe. Now let me take you to something that will reframe everything. The Hubble Ultra Deep Field. In 2004, the Hubble Space Telescope pointed at a tiny patch of sky, an apparently empty region in the constellation Fornax, about 1/10 the diameter of the full moon as seen from Earth. It stared at that patch for over 11 days, collecting light. What it found in that patch of seemingly empty sky was approximately 10,000 galaxies. 10,000 galaxies in a piece of sky smaller than a grain of sand held at arm's length. Each of those galaxies containing anywhere from a few 100 million to several trillion stars. And this patch was not special. It was chosen precisely because it appeared to be empty. The Hubble Ultra Deep Field is a fair sample of the universe at large. Wherever you look in the sky in any direction, the deep universe is filled with galaxies, shoulder to shoulder all the way back to the cosmic dawn. The most distant galaxies in the ultra-deep field are so far away that their light has been traveling for more than 13 billion years. We are seeing them as they existed when the universe was only about 5% of its current age. They are small, irregular, still in the early stages of formation, nothing like the grand spirals and ellipticals of the mature universe. Those galaxies have had 13 billion years to grow and change since the light we see was emitted. We do not know what they look like today. By now they are ancient. Their early stars have long since died. Whether they still exist as separate entities or have merged with others we cannot say. We see only their past. And their past is arriving at our eyes right now, tonight. The universe is a time machine in the most fundamental sense. Looking out is looking back. The further away something is, the older the image we are seeing. The present moment of a distant galaxy is forever hidden from us by the speed of light. We can only see history. In a sense, everything we see in the sky is memory. The universe is full of the light of things that happened long ago, still traveling, still arriving, still being received, like a letter that took a very long time to reach you, like a dream that lingers after waking. Let your eyes close if they want to. The galaxies will still be there, they always are. There is a galaxy called IC 1101 that I want to tell you about, because it is humbling in the most wonderful way. IC 1101 is the largest known galaxy in the observable universe. It is a supergiant elliptical galaxy located about 1 billion light-years from Earth, in the center of the Abell 2029 galaxy cluster. It is so large that if it were placed at the center of our own Milky Way, it would extend almost halfway the Andromeda galaxy. Its diameter is about 6 million light-years. The Milky Way is about 100,000 light-years across. IC 1101 is 60 times larger. It contains an estimated 100 trillion stars. That is 100 times more stars than our own galaxy. If our galaxy is a city, IC 1101 is a continent. It formed through the mergers of many smaller galaxies over billions of years. It sits at the center of a rich galaxy cluster and has slowly consumed neighboring galaxies over cosmic time, growing larger and larger, accumulating stars from its galactic neighbors the way a rolling snowball accumulates snow. And yet, for all its staggering size, it is quiet. Elliptical galaxies like IC 1101 are generally old, quiescent things. They have long since used up their star-forming gas. They are not having a starburst. They are not colliding dramatically with neighbors. They simply exist, vast and serene, holding their trillion stars in a smooth, rounded cloud. There is something deeply peaceful about IC 1101. The largest thing of its kind, and also one of the quietest, enormity and stillness together. Breathe that in. You do not have to be loud or active to be remarkable. You do not have to be doing something to matter. You can simply be, as IC 1101 is, immense in your own way, and still. Now I want to tell you about something closer to home, cosmically speaking, that is nevertheless as strange as anything in the distant universe. In our own local group of galaxies, there is a class of objects called ultra-compact dwarf galaxies, or UCDs. These are tiny things by galactic standards, typically only a few hundred light-years across, but surprisingly dense. They contain tens of millions of stars packed into a very small volume. The leading theory is that UCDs are not true galaxies at all, but rather the stripped nuclei of larger galaxies. A dwarf galaxy that fell into a larger galaxy and had its outer stars torn away, leaving only its compact, dense center intact. A galaxy, in other words, that has been reduced to its core, and yet those cores persist. Tens of millions of stars tightly packed, orbiting each other in a space much smaller than a full galaxy. Still shining, still there is something resilient about that image. A galaxy reduced to its heart, and the heart keeps going. Let me tell you about the Whirlpool Galaxy, Messier 51. The Whirlpool Galaxy is a beautiful face-on spiral galaxy, about 23 million light-years from Earth, in the constellation Canes Venatici. It was one of the first galaxies to be recognized as a spiral, long before anyone understood what a galaxy was. In 1845, the Irish astronomer Lord Rosse observed it through his enormous reflecting telescope, nicknamed the Leviathan of Parsonstown, and sketched its spiral structure, becoming the first person to see that shape in a nebula, as people then called all distant, fuzzy objects. He could not have known he was looking at a galaxy. The very concept did not yet exist. The scale of the universe was not yet understood. He drew what he saw, a beautiful spiral shape in the sky, and he noted it carefully. The Whirlpool Galaxy has a companion, a smaller irregular galaxy called NGC 5195, which appears to be passing behind and then through the spiral arm of the Whirlpool. The interaction between the two has enhanced the spiral structure of the Whirlpool, making its arms more prominent, triggering star formation, brightening the whole system. Together, the Whirlpool and its companion have been captured in some of the most iconic images of the night sky. Seen through a telescope, they look like a great spiral with a smaller attendant hanging nearby, the two connected by a streamer of material. There is something companionable about them. The big spiral and its smaller friend, together in the same patch of sky, influencing each other, not quite merging, at least not yet, just passing, interacting, changing each other. As most things do when they come close enough to matter. Take a slow breath. Let the muscles in your face soften, your forehead, your cheeks, around your eyes. There is nothing to look at that requires tension, just the darkness behind your eyelids and the galaxies beyond. I want to tell you about something called the cosmic web. The universe is not uniformly distributed. Galaxies are not spread evenly through space like raisins in a cake. Instead, they are arranged in a vast three-dimensional web of filaments, sheets, and voids. Clusters of galaxies are found at the intersections of the filaments, like pearls on a necklace. The filaments themselves are long strings of galaxies, stretching for hundreds of millions of light-years, and between the filaments are voids, enormous regions of space that contain almost nothing. Some voids are hundreds of millions of light-years across. This structure, the cosmic web, is the largest structure in the universe. Nothing larger exists as far as we know. It fills all of space. The cosmic web formed from tiny variations in the density of matter in the very early universe. The same variations that produced the subtle temperature differences we see in the cosmic microwave background, the faint afterglow of the Big Bang. Regions that were slightly denser than average attracted more matter. More matter made them denser still. Over billions of years, the slight variations amplified until galaxies and clusters and filaments emerged. The structure we see today is the result of nearly 14 billion years of gravity, doing its quiet, patient work. It is, in its way, a kind of breathing. The universe inhaled and gathered matter together, forming the cosmic web. And in the voids, almost nothing. A kind of exhale, a vast emptiness that makes the structures elsewhere more defined, filaments and voids. Gathering and emptying. Structure and space, like breathing, in and out. In and out. Let me tell you about a void. The Boots Void, sometimes called the Great Void, is an enormous region of space discovered in 1981. It is roughly spherical, about 330 million light-years in diameter, and contains very few galaxies. Where you might expect thousands of galaxies, there are only about 60 confirmed in the void. The rest of that vast sphere is nearly empty. The Bootis Void is one of the largest known voids in the universe. If you were inside it, looking out in all directions, you would see an approximately empty sky. The galaxies clustered around its edges would be too far away to see with the naked eye. You would be inside an immense darkness, and yet not complete darkness. There would still be stars. The few galaxies within the void still contain stars. And there would still be the cosmic microwave background, the faint warmth of the Big Bang, permeating space in all directions. Even in the emptiest place in the universe, you would not be in total darkness. There is something comforting in that. Now let me take you to one of the strangest and most beautiful discoveries in recent astronomy. In 2015, a team of astronomers announced the discovery of what they called the laniakea supercluster. Laniakea is a Hawaiian word meaning immeasurable heaven, and it is the supercluster of galaxies to which our own Milky Way belongs. Scientists had long known that the Milky Way is part of the local group of galaxies, which includes Andromeda, the Magellanic Clouds, and a few dozen smaller galaxies, all held together by mutual gravity. They knew the local group is part of a larger structure called the Virgo supercluster. But in 2015, using new techniques to map the flow of galaxies through space, they realized that the Virgo supercluster is itself just one part of a much larger structure. Laniakea is a supercluster of 100,000 galaxies, spanning about 500 million light-years. It contains the mass of about 100 million billion suns, and the Milky Way is in it. Right here, in one of the outer tendrils of Laniakea, a quiet neighborhood far from the bustling center, where the Great Attractor, a mysterious region of enormous gravitational pull, draws everything slowly inward. The Great Attractor, it is a real thing, not a science fiction invention. It is a region of enhanced density at the heart of Laniakea, pulling the Milky Way and everything else in the supercluster toward it at about 600 kilometers per second. Not that we feel it, not that it will matter on any human timescale. But we are moving, all of us, the whole Milky Way, towards something. We live inside a supercluster. We are part of a web of 100,000 galaxies, all slowly flowing toward a common center. And that supercluster is itself embedded in the cosmic web, surrounded by other superclusters, all part of the largest structure that exists. We belong. Not just to Earth, not just to the solar system, not just to the Milky Way. We belong to the local group and the Virgo supercluster and Laniakea and the cosmic web. We are woven into the largest tapestry that exists. Let your body be heavy. Let the surface beneath you do all the work. You do not need to hold anything up right now. Everything is fine. Everything is here. I want to tell you about a phenomenon called gravitational lensing, because it is one of the most magical things the universe does. When light passes near a massive object, it is bent. This is not because light has mass, but because massive objects curve space itself, and light, traveling through curved space, follows the curves. This was predicted by Albert Einstein as part of his general theory of relativity, and confirmed during the solar eclipse of 1919. When astronomers observed that the positions of stars near the Sun were shifted from their expected positions, just as Einstein had predicted, galaxy clusters, with their enormous mass, bend light significantly. When light from a distant galaxy passes through or near a foreground galaxy cluster, it is bent, stretched, and sometimes magnified. We see distorted images of the distant galaxy, sometimes multiple copies of it, sometimes stretched into long arcs, sometimes bent into complete or partial rings called Einstein rings. The Hubble Space Telescope has captured many extraordinary examples of gravitational lensing. Some of the most beautiful images in astronomy show blue arcs of distorted light from distant galaxies, wrapped around the warm yellow glow of foreground clusters. Galaxy clusters are, in effect, natural telescopes. They take light from objects even further away and focus it, magnify it, bring it within reach of our instruments. Some of the most distant galaxies we have ever observed were only detectable because a foreground cluster lensed and amplified their light. The universe is helping us see itself. Gravity, which curves space, which bends light, is not just a force of attraction. It is also a lens, and that lens can reach across billions of light-years to bring us glimpses of the earliest galaxies, the first generation of stars forming in the dawn of time. Let your breathing be slow and even. There is no rush, there is nowhere to be. Just here, just now, just the quiet and the dark and the immensity of everything. There is a class of objects called quasars that I want to tell you about. In the 1950s and 1960s, astronomers discovered radio sources in the sky that seemed to correspond to point-like optical objects, like stars but not stars. They were called quasi-stellar objects, quickly shortened to quasars. For years they were mysterious. They emitted extraordinary amounts of energy from what appeared to be very small regions of space. We now understand what they are. Quasars are active galactic nuclei. They are the cores of distant galaxies in which supermassive black holes are actively accreting, feeding on enormous quantities of gas and dust. As material falls toward the black hole, it forms a hot rotating disk called an accretion disk, and the energy released by this process is immense. A quasar can outshine its entire host galaxy by a factor of 1,000 or more. The most powerful quasars shine with the brightness of 40 trillion suns. Most quasars are very far away, which means we see them as they existed long ago, when the universe was younger and more gas-rich and supermassive black holes were more actively feeding. As the universe aged and the available gas was consumed or dispersed, quasar activity declined. The universe today is quieter than it was in its youth, but some quasars remain. And the phenomenon that created them, the accretion of matter by supermassive black holes, continues in less extreme forms in many galaxies today, including, in a very subdued way, in the center of our own Milky Way. The supermassive black hole at the heart of our galaxy is called Sagittarius A, pronounced Sagittarius A star. It has a mass of about 4 million solar masses, much smaller than the black holes in quasars, and is currently very quiet, eating very little. Occasionally it flares slightly as a small cloud of gas or a star passes and is partially disrupted. But for the most part, it sits there at the center of our galaxy, patient and dark. It is about 26,000 light-years from us. We will never visit it. But it is there at the center of the thing we live in, a dark heart, and it is fine. We are fine. 26,000 light-years is a comfortable distance. Everything is at a comfortable distance tonight. Let me tell you about green peas. Not actual peas, green pea galaxies. These are a class of compact, intensely star-forming galaxies discovered in 2007 by volunteers participating in the Galaxy Zoo project, a citizen science initiative that asks members of the public to look at images of galaxies and classify them. The green pea galaxies were found by volunteers who noticed a category of object that didn't fit the standard classifications: small, round, green-looking objects. They reported them, and astronomers investigated and found they were looking at a distinct class of galaxy. They are compact, typically only a fraction of the size of the Milky Way, and they are undergoing intense star formation at a rate far higher than normal. This star formation produces enormous amounts of ionizing radiation, and the specific light emitted by oxygen gas in these galaxies appears green, which is how they got their name. Green pea galaxies also appear to be very efficient at producing something called Lyman continuum photons, a type of ultraviolet radiation that can escape from the galaxy and ionize the surrounding gas. This makes them interesting to cosmologists studying reionization, the early period in cosmic history when the first galaxies and stars lit up and ionized the neutral hydrogen that filled the universe. The green peas may be local analogues of the very first galaxies, stand-ins for objects we cannot otherwise see because they are too distant. By studying green peas nearby, we can learn about what the universe looked like when it first began to shine. It is a lovely thought that ordinary people clicking through images on their computers found something genuinely new and scientifically important, that the universe's secrets were unlocked, at least in part, by curious humans with no particular expertise except the willingness to pay attention. Pay attention. Look carefully. There are things worth seeing everywhere if you are willing to look. But for now, let your attention rest. Let it drift. Let it go wherever it wants. Breathe in and out. I want to tell you about Hoag's object. In 1950, Arthur Hoag, an astronomer, noticed something unusual while examining photographic plates of the sky. A perfect ring of blue stars surrounding a smooth yellow elliptical nucleus, with a gap of almost perfect darkness between them. He wondered if it might be a planetary nebula, the shell of gas expelled by a dying star. He wondered if it might be a gravitational lens. He wasn't sure. We now know it is a galaxy, classified as a ring galaxy, similar in some ways to the Cartwheel galaxy we visited earlier, but even more symmetrical and mysterious. The ring of Hoag's object is nearly perfectly circular, the nucleus is smooth and featureless, and the mechanism that created this configuration is still debated. One theory is that it formed from the collision of two galaxies, with a smaller one passing through the center of a larger one and triggering the formation of a ring of stars. Another theory involves a bar of stars that dissolved over time, leaving the ring behind. No one is entirely certain. What makes Hoag's object even more extraordinary is this. Through the gap between the nucleus and the ring, you can see another ring galaxy, even further away. A ring galaxy visible through the ring of Hoag's object, like nesting dolls, like a ring within a ring coincidence. That outer galaxy just happens to be in the right position in the distant background. But it is a remarkable coincidence, and the image is one of the strangest and most beautiful in astronomy. A ring containing, in the gap between its parts, another ring. The universe occasionally arranges itself into compositions so improbable they seem intentional. We know they are not. And yet, let me tell you about light. All the light you have ever seen in your life has been the same thing. Electromagnetic radiation, Photons, massless particles that travel at about 299 million meters per second in a vacuum. The photons of sunlight that warm your skin. The photons from a lamp that let you read. The photons from a distant star that made you look up. All of them are the same kind of thing, just at different energies, different wavelengths. The photons in visible light, the ones your eyes are sensitive to, have wavelengths of between about 380 and 700 nanometers. A nanometer is 1/1000th of a meter. The difference between red light and violet light, the whole range of human visible color, is a span of 320 nanometers, which is about 320 billionths of a meter. The universe produces electromagnetic radiation across a far larger range. Radio waves, microwaves, infrared, ultraviolet, X-rays, gamma rays, all of them are the same kind of thing at different energies. Visible light is only a tiny sliver of the electromagnetic spectrum, and it is the tiny sliver that our eyes happen to be sensitive to. Galaxies, in different parts of the spectrum, look completely different. In radio waves, Centaurus A's jets dominate everything. In X-rays, the hot intracluster gas of the coma cluster glows brightly. In infrared, dusty star-forming regions shine where visible light shows only darkness. In ultraviolet, young hot stars blaze where older stars are invisible. There are whole aspects of the universe that we cannot see with our eyes, but that are real and present and extraordinary. The universe is, in every direction, full of invisible light. We built instruments to see what our eyes cannot. We made ourselves wider sensors. We expanded our perception outward into wavelengths our biology never evolved to detect. We are persistent, curious creatures who refuse to accept that what we cannot see does not exist. And the universe has rewarded that persistence with wonders. The James Webb Space Telescope, launched in December 2021 and operational since 2022, is the most powerful space telescope ever built. It observes primarily in the infrared, allowing it to see through dust clouds that block visible light, and to detect the redshifted light of the earliest galaxies. It has already returned images and data of unprecedented quality, revealing star formation regions in the Carina Nebula in extraordinary detail, observing the atmospheric composition of exoplanets, and detecting galaxies from the first billion years of the universe's existence. One of its first science images was of a cluster called SMACS 0723. The image showed thousands of galaxies, including multiple arcs produced by gravitational lensing, in a patch of sky smaller than a grain of sand held at arm's length. Some of the lensed objects were among the most distant ever observed. It took only 12 hours of observation to produce that image. The universe is patient. It has been sending its light to us for billions of years. We finally built something capable of catching more of it. Your breath is slow now, I imagine. Slower than when we started. That is good. That is what we are here for. The galaxies are still out there, patient and enormous, indifferent to whether you are awake or asleep. They will be there when you wake up. They will be there tomorrow, and for billions of years beyond tomorrow. There is no urgency. There is only now. Let me tell you about something called the Pillars of Creation, even though it is technically a nebula and not a galaxy, because it is too beautiful to leave out, and it lives inside a galaxy, our galaxy, which counts for something. The Pillars of Creation are a region of active star formation in the Eagle Nebula, about 6,500 light-years from Earth. They are columns of interstellar gas and dust, several light-years tall, their tips eroded by the ultraviolet radiation from nearby newborn stars. They glow with the gentle color of ionized gas. They were first photographed by Hubble in 1995, and the image became one of the most iconic in the history of astronomy. The James Webb Space Telescope photographed them again in 2022, in infrared light, revealing details invisible to Hubble, including newly forming stars buried in the dust of the pillars themselves. Here is something strange and poignant about the Pillars of Creation. A 2007 study using the Spitzer Space Telescope suggested that a supernova approximately 8 to 9,000 years ago may have sent a shockwave that will eventually destroy the pillars. The destruction would have happened roughly 1,000 years ago, from our perspective today, but because the pillars are 6,500 light-years away, we will not see the destruction for about another 1,000 years. The image of them that we see now is already 6,500 years old. We may be admiring something that no longer exists. That is not sad, I think. It is a reminder that the universe is a record. The light we see is history. And history can be beautiful even when it has passed. Even the most transient things leave light that travels. Let your thoughts slow now. Let them become simpler, softer, images without edges, words without urgency. I want to tell you about the oldest light in the universe. The cosmic microwave background, or CMB, is the afterglow of the Big Bang. In the first 380,000 years after the Big Bang, The universe was so hot and dense that it was opaque, filled with plasma too hot for atoms to form. Light could not travel. It was constantly scattered and reabsorbed. Then, as the universe expanded and cooled, atoms finally formed. Protons and electrons combined into hydrogen. The universe became transparent. The light that had been trapped in that hot plasma was finally free to travel, and it streamed outward in all directions. That light is still traveling today. In 13.8 billion years of cosmic expansion, it has been stretched by the expansion of space until it is now in the microwave part of the spectrum. Far too long a wavelength for our eyes to detect. But it is there. It fills all of space. It comes from every direction equally. Right now, as you lie wherever you are lying, microwave photons from the Big Bang are passing through you, through the walls of your room, through everything, in every direction. You are bathed in the light of the Big Bang, always. Without noticing, the CMB is almost perfectly uniform, the same temperature in every direction to extremely high precision. But it is not quite perfectly uniform. There are tiny variations, fractions of a degree, regions slightly warmer or cooler than average. These fluctuations correspond to slightly denser and slightly less dense regions of the early universe, the seeds of the cosmic web, the ancestors of all the galaxies that would form over the following billions of years. Those tiny fluctuations in the early universe became the cosmic web. Every galaxy cluster, every filament, every void, had its origin in those early density variations. The universe we live in, with all its extraordinary structure, all its galaxies and stars and planets and us, grew from seeds that were already present in the light of the Big Bang itself. We are the universe's way of looking at itself. We are the descendants of quantum fluctuations in the early universe, evolved and complicated and curious, looking out into the darkness and wondering. Let your wondering rest for a while. There is nothing you need to figure out tonight. The universe has been at work for almost 14 billion years, and it does not need your help. You can simply be in it. I want to tell you about a peculiar and wonderful thing called a polar ring galaxy. Some galaxies have a structure that defies easy description. A polar ring galaxy has two distinct components: a central galaxy, typically a lenticular or elliptical type orbiting in one plane, and a ring of stars, gas and dust that orbits the central galaxy in a plane almost perpendicular to the main disk, like a gyroscope, like a globe with a ring around it that circles from pole to pole rather than around the equator. The most well-known example is NGC 660, about 45 million light-years away, and another is Hoag's object, though that one has its own mysteries. The formation of polar rings is thought to involve the accretion of material from a companion galaxy or from intergalactic gas clouds, material that fell in at a strange angle and settled into a perpendicular orbit. The result is a galaxy with two completely different rotation axes. Stars in the main body orbit in one direction, stars in the ring orbit in a completely perpendicular direction. Seen from the right angle, they look like something that should not be able to exist. A physical impossibility somehow resolving itself into a stable structure. Gravity manages it. Given time, even the most improbable configurations can achieve a kind of stability. There is something reassuring about that what seems impossible can find a stable form. That strange configurations can persist. Let your breathing find its own rhythm. Deep or shallow, fast or slow, whatever it wants. Your body knows how to breathe. You have been breathing for your entire life without having to think about it. Even when you sleep, it continues. The universe continues too, without anyone attending to it. Let me tell you about galaxy groups and how they show us that nothing in the universe is truly alone. Our Milky Way is part of the local group, a collection of about 50 to 80 galaxies bound by gravity, spanning roughly 10 million light-years. The dominant members are the Milky Way and Andromeda, with many smaller galaxies orbiting them or simply moving through the group. Most galaxies exist in groups or clusters. Isolated field galaxies, galaxies with no nearby companions, are relatively rare. The cosmos is a social place, in its slow and gravitational way. Things gather together, they influence each other, they interact. Galaxy groups interact with each other too. The local group and the M81 group and several others are all part of the Virgo supercluster, which is itself part of Laniakea. Everything is nested within something larger. There is no top level. The cosmic web is just structure all the way up, patterns within patterns, each embedded in a larger pattern. This is also true of the small atoms made of protons and neutrons and electrons. Protons and neutrons made of quarks. Quarks held together by gluons. Everything is made of something smaller, and everything is part of something larger. The universe is nested structure from the smallest to the largest scale. And somewhere in the middle of all that nesting is you. A collection of atoms arranged into a body, lying somewhere comfortable, listening to words about the universe. You are the universe being aware of itself. One of its more improbable arrangements, Let that be enough for tonight. I want to tell you about a galaxy called ARP-87, because it is a love story of sorts. NGC 38808 and NGC 38808A are two galaxies in the process of a close interaction, catalogued together as ARP-87 in Holton Arp's Atlas of Peculiar Galaxies. They're about 300 million light-years from Earth. A Hubble image of them shows a large barred spiral galaxy, with a bridge of stars stretching from it toward a smaller companion galaxy below. The bridge is a stream of stars and gas pulled out by the mutual gravitational attraction of the two galaxies. Billions of stars in that bridge. Stars that were once part of one galaxy, now in transit, flowing through the space between the two galaxies like sand in an hourglass. The galaxies are approaching each other. They will eventually merge, in perhaps a few billion years. The bridge of stars will thicken. The two disks will disrupt each other. Eventually there will be one galaxy where there were two, something new formed from the combination. The image shows a moment in that process. The bridge, the slow drawing together, the beginning of what is, on cosmic timescales, an inexorable approach. And in all those stars in the bridge, in all those stars in both galaxies, there are very likely planets. And on some of those planets, who can say what might be aware of the extraordinary sky it lives under? Two spiral galaxies, one large, one small, connected by a glowing bridge, drawing slowly together over billions of years. What would it be like to see that sky every night? To live under it and wonder? We will never know. But we can imagine. The universe is large enough to contain all the questions we can imagine, and probably most of the answers. Let your imagination go soft. Let it run without direction. Let it drift the way light drifts across a room. I want to tell you about the Virgo cluster, about 54 million light-years from Earth. The Virgo cluster is the nearest large galaxy cluster to us and the gravitational center of the Virgo supercluster, which includes our own local group. The Virgo cluster contains over 1,300 galaxies, including several very large elliptical galaxies, and Messier 87, the galaxy with the famous black hole image. The cluster is enormous, spanning several million light-years in diameter. Its center is dominated by three massive elliptical galaxies, M87, M86 and M84. Around them, hundreds of smaller galaxies orbit, move, fall in, stream past. The Virgo cluster exerts a gravitational pull on the local group. We are moving toward it, though not so quickly that we will fall in on any relevant timescale. More precisely, we are falling toward a region called the Great Attractor, which lies beyond the Virgo cluster, and the Virgo cluster is itself on the path. Everything is moving. The Milky Way is moving through space at about 600 kilometers per second, relative to the CMB. The solar system is orbiting the center of the Milky Way at about 220 kilometers per second. Earth is orbiting the Sun at about 30 kilometers per second. You are moving right now, even as you lie still, at tremendous speed in multiple directions simultaneously. It does not feel like it. It feels like stillness. Because you are moving with everything around you, and there is nothing local against which to feel the motion, stillness and motion. Depending on your reference frame, you are at rest. The universe is in motion. Both things are true. Let your body be still. Let everything be at rest. Let the motion of the universe carry you without your having to do anything. Now, let me tell you about something that was discovered very recently and is still being understood. In 2022, the James Webb Space Telescope began returning data that challenged some of our assumptions about how early the first galaxies formed. It detected galaxies from the first few 100 million years of the universe's existence that were more massive, more structured, more like mature galaxies than the models had predicted. Galaxies that, according to our best understanding of how structure forms in the universe, should not yet have been so large. This is not a crisis for physics. Not yet. It is more of a puzzle, a productive puzzlement that tells us our models are incomplete. Perhaps the first stars and galaxies formed more efficiently than we thought. Perhaps dark matter behaves in slightly different ways than our standard models assume. Perhaps we are missing something. Science is full of these productive puzzles. Data arrives that does not quite fit the models. The models are refined. New theories are proposed and tested. Understanding deepens. The universe is under no obligation to be simple. It has had 13.8 billion years to develop complexity, and it has made full use of that time. We are still learning. We will always be learning. That is not a weakness. That is the most honest and wonderful thing about trying to understand the universe. Let me tell you about something called the Sunyaev-Zeldovich effect, which is one of the most beautiful and unexpected things that happens in the universe. When photons of the cosmic microwave background pass through a galaxy cluster, they encounter the hot electrons in the intra-cluster gas. The electrons kick the CMB photons to higher energies, a process called inverse Compton scattering. This shifts the CMB photons slightly in energy in a characteristic way that can be detected. The result is that galaxy clusters leave a kind of shadow in the CMB, a region where the microwave background appears slightly altered by its passage through the hot gas of the cluster. Astronomers can use this effect to detect galaxy clusters at very large distances, because the effect does not depend on how far away the cluster is. A cluster at 1 billion light-years shows the same signal as a cluster at 10 billion light-years. This makes the Sunyaev-Zeldovich effect one of the most powerful tools for finding distant galaxy clusters and studying how clusters have formed and evolved over cosmic time. A shadow in the light of the Big Bang, cast by a cluster of galaxies. We detect it with sensitive microwave detectors, and from that shadow we learn the mass and temperature and position of the cluster. The universe is full of signals, if you know how to read them. Every photon carries information. Every variation in the CMB is a message from the early universe. Every gravitational wave is a ripple from a cataclysm billions of light-years away. We are learning to listen. You can let your listening become diffuse now, not focused listening. Just open, receptive, soft attention. The way you might listen to rain on a roof without tracking any particular drop. Let me tell you about galaxies at the edge of the observable universe. The observable universe extends in all directions to a distance of about 46 billion light-years. This is larger than the age of the universe, times the speed of light would suggest, because space itself has been expanding during the time the light has been traveling. The light from the most distant objects we can observe left its source when the universe was only a few 100 million years old, and the source has since moved far further away as space expanded. At the edge of the observable universe, we see objects from a time when the universe was very young, very hot, very energetic. The first galaxies were small, irregular, turbulent things, nothing like the grand spirals and ellipticals of the mature universe. They were forming the first heavy elements, the first metals beyond hydrogen and helium, which the Big Bang produced in the first few minutes. Those first heavy elements were scattered by supernova explosions and built into the next generation of stars, and the next, and the next. Every generation of stars enriched the galaxy's gas a little more, adding more of the elements heavier than helium. The atoms in your body, the carbon in your cells, the oxygen in your blood, the calcium in your bones, the iron at the center of your hemoglobin, all of it was forged in stars and scattered by their deaths across billions of years, across countless generations of stars, before eventually coming together in this solar system, on this planet in you. You are made of stardust. Not metaphorically, literally. Every heavy atom in your body came from a star. You are part of the universe observing itself, part of the cosmic process of matter becoming complex enough to wonder about itself. That is extraordinary. It is also, in its way, deeply peaceful. You are not separate from the universe. You are the universe, in one of its temporary and improbable configurations. Breathe that in and out. Let me tell you about elliptical galaxies, the quiet elders of the cosmic community. Spiral galaxies like our own are active, star-forming things, their arms full of gas and young blue stars, their disks busy with the ongoing process of stellar birth and death. Elliptical galaxies are different. They are the result of mergers most often, the products of spiral galaxies colliding and combining over billions of years. The violence of those mergers disrupts the orderly disk structure and heats and disperses the gas, leaving behind a smooth, rounded system of mostly old stars. Elliptical galaxies range from small, dim spheroids barely the size of a globular cluster, through medium-sized systems, to the giant ellipticals at the centers of rich galaxy clusters, some of the largest objects in the universe. They come in all sizes, but they share a character: smooth, featureless, mostly red and gold in color because their stars are old, and in many cases no longer forming new stars at all. They are the products of history. Each merger that contributed to an elliptical galaxy left traces in the distribution of its stars, in the streams and shells and tidal features that can sometimes be seen at the edges of ellipticals in very deep images. A large elliptical galaxy is a palimpsest, a text written over and over, each merger adding a new layer to the story. There is something beautiful about old things, about things that carry their history and their structure, about things that have been changed by everything that has happened to them, and yet persist. An elliptical galaxy is a record of all the galaxies that fell into it. All their stars now orbit together in the same smooth system. All their histories combined, nothing is lost. It is transformed. Let your thoughts become softer, less sequential. Let them become images rather than words. I want to take you somewhere very specific now. In the Hercules constellation, about 860 million light-years from Earth, there is a string of 4 galaxies called Stephan's Quintet. Except it is not actually a quintet. 5 galaxies were originally catalogued together, but one of them turns out to be a foreground galaxy much closer to us, only about 40 million light-years away. It only appears to be associated with the others because of a chance alignment. The remaining 4 are a genuine compact group, 4 galaxies in close proximity, interacting with each other, their gravitational tugs distorting each one. Between 2 of them, a 5th galaxy, NGC 713b, is plunging in at high speed, creating a shock wave in the intracluster gas that glows in X-rays and radio waves, a wave of heat moving through the gas between the galaxies. The James Webb Space Telescope observed Stephan's quintet in 2022, and the image is extraordinary. 5 galaxies, 4 in close interaction, 1 a chance alignment, their structures visible in unprecedented detail. The shock wave between the interacting galaxies, the streams of stars pulled out by their mutual gravity, the reddish halos of old stars, and the bluer regions of new star formation. In the foreground galaxy, sharp blue spiral arms. In the background 4, the warm gold of old stellar populations, and the disrupted shapes of long interaction. It is a portrait of time. Different stages of galactic life in a single image. The universe does not hide its processes. If you look carefully enough, with sensitive enough instruments, it shows you everything. The collisions, the mergers, the shock waves, the births, the quiet old ages, all of it visible, all of it happening. You do not have to do anything with this. You do not have to understand it fully. You can simply receive it, the way you receive warmth from sunlight, without understanding thermodynamics, the way you receive music without understanding acoustics. Feel the warmth of all those distant fires. Breathe. Let me tell you about something called cosmic evolution, the grand arc of how the universe has changed over 13.8 billion years. The universe began in a state of extraordinary simplicity, extremely hot, extremely dense, almost perfectly uniform. Only the lightest elements existed: hydrogen, helium, a little lithium. There were no heavy elements, no planets, no stars, no galaxies, just hot plasma and expanding space. As the universe expanded and cooled, atoms formed, gravity began to amplify the tiny density variations we discussed earlier, and the first stars lit up about 100 to 200 million years after the Big Bang. These first stars, called population 3 stars, were made almost entirely of hydrogen and helium. They were likely very massive, burning hot and bright and dying quickly. When they died in supernova explosions, they scattered the first heavy elements into the surrounding gas.